We're going to look at a fairly complicated rational function to graph now, and we're going to work through all the steps in detail. This video will be in two parts, so this is part one of the process. And so we're graphing f of x equals x squared minus 9 over x squared plus x minus 2. That's our goal, to get a graph of this function. And we're going to follow the process that's on the sheet posted in Canvas, the graphing function, rational functions, step by step, right? Step 1, 2, 3, so on and so forth. And so in step 1, the first thing we're going to do is check for vertical asymptotes. I'm going to use the abbreviation VA for that. And we know that as long as our rational function is in reduced form, that we can find the vertical asymptotes by setting the denominator equal to 0. And I will only give you examples that are already in reduced form, so you won't have to check ahead of time. So this is reduced. I checked it ahead of time before I gave it to you. And so we're going to set x squared plus x minus 2 equal to 0, and we got to solve. And this is a quadratic that we can possibly factor. Let's see. And let's see, we got 2 times 1. If I do plus 2 minus 1, I think that will work out. That gives me the x middle term. And so I can factor, and so x plus 2 equals 0, or x minus 1 equals 0. So x is equal to negative 2, and x equals 1. We have two vertical asymptotes, right? So just notice that we got two vertical asymptotes for this graph. And now I'm not going to do the graphing in this segment. We'll do that in the second part of the video. First, we're just going to gather some information about the graph. So second step is to check for the horizontal asymptote. That I'll often just write HA from now on for that. And we have our little test to check, right? So it's summed up on our sheet. We compare the degree of the numerator and denominator of the rational function. And here, both the numerator and denominator have degree 2. So degree P equals degree Q. So you can just use this formula for the horizontal asymptote equation. The horizontal asymptote equation is going to be y equals the lead coefficient of the numerator over the, let's write lead coefficient of P over the lead coefficient of the denominator of Q. And so here, those are both 1, right? We have 1 times x squared and 1 times x squared in numerator and denominator, so it's y equals 1 over 1, or just y equals 1 is the horizontal asymptote. And there can only be one horizontal asymptote. There can never be more than one. And I did set what we found out so far up on a graph grid just so you can see. It's good to do your graphing on graph paper. Use rulers, and accuracy helps because it'll make it easier to draw a nice graph. So notice I have two vertical asymptotes drawn at -2 and 1. And I have the one horizontal asymptote drawn on my graph so far. Step 3 is to find the x and y intercepts, which usually are not too hard to calculate, so that's why we like to find those points. I'll do the y-intercept first, so I'll set x equal to 0. F of 0 for this function is 0 squared minus 9 over 0 squared plus 0 minus 2. I'm just going to get minus 9 over minus 2 out of that, or 9 halves, or 4.5. So that's actually the 0.0, 4.5. Okay. And x-intercepts, I'm going to set the function equal to 0, or the y equal to 0. So I'm going to set 0 equal to x squared minus 9 over x squared plus x minus 2, and solve for x. And here, I don't mind if you use a shortcut, because the only way a fraction can be equal to 0 is if the numerator is equal to 0. But I just want to spell out why that works. I mean, basically what we're doing is we're going to multiply both sides by the denominator of this fraction, which is x squared plus x minus 2. That's to clear fractions. And if you multiply both sides by the denominator, what will always happen? So that's the denominator over 1 on the right-hand side. This will cancel on the right, so we have just the numerator, x squared minus 9. And the left-hand side will still be 0, because anything times 0 is itself. So there we have 0 equals the numerator, and we got to solve. Now you can either break this down, factor this as a difference of squares, or solve the quadratic equation here. Difference of squares is x minus 3, x plus 3 factorization. So x minus 3 equals 0, or x plus 3 equals 0. And I get x equals 3, or x equals minus 3. And so I have two x-intercepts. I have 3, 0, and negative 3, 0 that I can add to my graph. And now step 4. Here's something we haven't done yet. Check to see if the graph crosses the horizontal asymptote. Set f of x equal to the horizontal asymptote value and solve for x. So it's possible that there can be points on our graph that lie on this horizontal asymptote. And so that's what we're trying to find. Our horizontal asymptote is y equals 1. And so it's that y value of 1. So I'm going to take my function, f of x equals x squared minus 9 over x squared plus x minus 2. And I'm going to set the function equal to 1. So that's from my horizontal asymptote, y equals 1. And so set the y value equal to 1 and solve for the corresponding x. Okay, solve for x. Now, to do this, I'm going to continue on this sheet of paper here. This is kind of similar to finding x-intercepts, but kind of different too. So what I want to do is clear fractions again. So again, I'm going to multiply both sides by that denominator, x squared plus x minus 2 times 1 equals x squared minus 9 over x squared plus x minus 2 times that denominator, x squared plus x minus 2, which I can write over 1 on the right-hand side. And it will cancel. And kind of like with the x-intercepts, I get x squared minus 9 on the right. But now on the left, I don't have just 0, right? Because I'm taking that denominator times 1. I'm going to still have x squared plus x minus 2. If I had a different number here, I would have to distribute through those terms. So I have x squared plus x minus 2 equals x squared minus 9. And I still got to solve for x. All right, I'm still solving for x. And I can subtract x squared from both sides here. So it looked kind of like I was getting a quadratic equation, but because I can subtract x squared from both sides, I end up with just x minus 2 equals negative 9. And then I can add 2 to both sides. And I'm going to move over because I'm coming up against some other stuff here. I get x is equal to negative 9 plus 2. X is equal to negative 7. So I got a solution. Now x is equal to negative 7, comma, the corresponding y coordinate was 1 because we set y equal to 1 to get that. So we have negative 7, 1 as a point on our graph. That's a point where the graph crosses the horizontal asymptote. So let's just put these intercepts and these points, whoops, upside down, on our picture. We had the y-intercept 0, 4.5. 0, 4.5 is going to be right there. We had the x-intercepts 3, 0, negative 3, 0. So we have those 2 points on our graph. And we also have this now, this point where we cross the horizontal asymptote at negative 7, 1. So negative 6, negative 7, 1 is right there. That's a point on the graph that lies right on the horizontal asymptote. And I'm going to stop here. We're going to finish this in a separate video. So to be continued. The suspense mounts.